Hello everyone, I hope you're doing well. So in today's video, we are going to go through the 2019 Specialist Maths Exam 2 of the multiple choice section. And like always guys, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me for this email. I hope this video helps you with your studies and let's smash through this video. So question 1. The graph of f of x, this does not have what? So does it have a horizontal asymptote, vertical asymptote, local minimum, vertical axial intercept, or point of inflection? What we can just do here is just graph it using our CAS. Let's go to our CAS and let's graph it. So what is basically, so e to the x minus 1, enter. And let me zoom out. I don't think it's, let me zoom out. There it is. This is what the graph looks like. Now, okay, does it have first a, you remember we want not, like which one does it not have? But first let's have it. Does it have a horizontal asymptote? Yes, it does. You can see how there's a horizontal asymptote at y equals 0. So it's not that one. Does it have a vertical asymptote? Yes, it does. As you can see here, there's a vertical asymptote at x equals 1. Does it have a local minimum? Yes, it does, right over there. Does it have a vertical axial intercept? So basically a y-intercept? Yes, it does. And does it have a point of inflection? Absolutely not. It doesn't look like it has a point of inflection. And we can actually just double check that by going inflection point. Really not no way there's an inflection point. So it's actually question 1 is E. So let's choose E. Question 2. The asymptotes of the graph of f of x, x squared plus 1, 2x minus 8 has equations of what? A really nice question. What we can do is we can expand this using our calculator. So let's do that. Let's go back to our calculator and write expand to make it back to its proper fraction form. X squared plus 1, 2x minus 8, comma x. And let's write this down over here. Let's write it down in our paper. So f of x can actually be written as 17 over 2x minus 4 plus x on 2 plus 2. So here we have an actual oblique asymptote. So this is a y equals x on 2 plus 2 asymptote. And of course, remember you solve where the denominator equals 0. Remember, you solve the denominator when it equals 0, it will give you the vertical intercepts. So your vertical asymptote, sorry. So it's x at x equals 4. So these are our two asymptotes at x equals 4, and we have an oblique asymptote at x over 2 plus 2, which gives you question 2. Question 2 is C. Perfect. Question 3. The implied domain of the function of the rule of this is what? Let's just do this with our CAS. So let's go back to our CAS and write domain 1 secant x plus pi over 4 comma x equals what? And so this is our domain. So all reals except this value. Let's write that down in our paper. So the domain should be all reals except this point over here, which is basically 4n minus 3 pi over 4, where of course where n has to of course be an integer. Now of course it's not A, it's not all reals, and it's not B, so it's one of these over here. Well, which one? Because you know how it's not the same thing. Like this has a 3, these have different values, so we don't know which one to pick. One of the best ways that I would do this is just basically put some values in. For example, if I let n equal 0, because this is my real equation, yeah. If I let n equal 0, what's it going to give me? It will give me negative 3 pi on 4 as one of my values. What other values? Like for example, if I put 1, if I put 1, it gives me pi on 4. If I put 2, it gives me 5 pi on 4. So these are the real. So what I'm going to do is I'm going to try to put these put some values and hopefully get these values over here. If I don't get them or skip them, then they are wrong. So let's try to check C first. Of course, no wait, let's check E because it looks quite different. So if I something 0, it's going to give me negative pi on 2, which is actually nowhere to be found. It's nowhere to be found here actually. So absolutely rubbish. The next one is, let's try C. So if I something 0, it'll give me negative pi on 4. Wait, absolutely rubbish. There is no negative pi on 4 in here. So it's not within here. Can you see negative pi on 4 is not inside here? So that's also wrong. Let's try D. If I sub in 0, it'll give me pi on 4, which is one of my values. Let's just double check that again. Let's say if I sub in 1, it'll give me 5 pi on 4, which is one of my values. If I sub in, let's say, negative 1, it'll give you negative 3 pi on 4. It's actually D then. Really, really nice question using your CAS to your advantage here. Question 4. The expression this is equal to what? So let's have a really breakdown of what's happening here. So you're saying I to the power of 1 factorial, which is just basically 1, basically I to the power 1, which is, yep. Then the next one is I, like 2 factorial. 2 factorial is 2 times 1, so it's I2 to the power 2. Plus I 3 factorial, so 3 factorial is 3 times 2, which is 6. Plus I to the 4 factorial going to 100 factorial, of course. But there has to be like in an exam, they're not going to give you something that looks like this. That's too hard. There has to be a pattern that we're looking for. So if I do I to the power 4, isn't it 4 times, 3 times 2 times 1? Woo, this is actually crazy because can you see how it's a multiple of 4? What happens if we have a multiple of 4 in terms of I to the power of a multiple of 4? You remember, if I have something like I to the power 4, it's equal to 1. If I have I to the power of 8, which because 8 is a multiple of 4, it's also equal to 1. So anything that's a multiple of 4, basically like this, I to the power of something like, anything that's multiple of 4, let's say 12, blah, 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 just anything that's a multiple of 4, it's going to always equal to 1. And if you kind of think about it, the other stuff are going to be equal, the rest of the other stuff, till you reach 100, are going to be multiplied like a multiple of 4. Because remember, it's a factorial. Like, for example, can you see how, like, I to the power, like 4 factorial gives me, look, can you see how it gives me, in terms, it has a 4 times a multiple of 4? And what about the other one? What about 5 factorial? So 5 times 4. Can you see how we're like 5 times, like you have a 4 there, times 3 times 2. And then what about the other one? 6 factorial, 6 times 5 times 6 times 4. And then you're still having that 4 there. It's going to just go there till 100. So guess what? What's going to happen is if you think about it, break it down, we know the rest of the stuff after this are going to be, until you reach, of course, 100 factorial, which is also going to be also 1, by the way. So think about it like this. So we already have 3 here. So you know how we're reaching to 100 factorial, which then there has to be 97 left. So you know how there's going to be 97? The other ones. You know how they're all going to be added up to 1? Like, basically like I to the 4 factorial is, that. Or I to the power of 5 factorial, it's also 1. So imagine going to 100. There's going to be 97 of them till you reach 100. Because remember, you already have 3 here. And remember, the total is 100. So we already made 3 here. So the other ones are going to be, 97. So there's going to be a 97. That actually simplifies to 97. And, okay, I to the power of 2 is just -1. And I to the power of 6, it's not a multiple of 4, but imagine like 6 divided by 4, what's the remainder is I squared, which is again -1, plus 97. And so that equals, I to the power, no, so plus 95. That simplifies to that. Which one's that? Looks like C. A really nice question to really break down. It looks hard, but it's easy. Now, there's also a way you can do it with a CAS, which is quite more easier, because if you think about it, it's like can you see how they're all being added? We can use summation here. Can you see how they're being added? Like, we can, a series of summations. So, for example, if I use the summation formula here, now you are able to use it, of course, because you are doing proofs this, in the new study design, so you're able to use this. Or what about if they were multiplied? You would use the product, which is this big pi over here. But because we're summing, we're going to have to use this. So so what's the formula? What's the basic formula? It's actually I to the power of, let's call it n factorial, because n can be any value. Yep. So 1, 2, 3, of course, n is an integer. And where are we starting? Well, we're starting at n equals 1. And where are we going? Well, we have to reach 100. So 100. So we can put this in our CAS, and our CAS will actually simplify it. Let's do that. So what we can do is press next to the book. We can go to the summation formula. N equals 1 to 100. I to the power of n factorial, which you can get factorial, just go menu, probability and factorial. And we can enter and we get the answer. Really, really beautiful right there. So there it is. All right. Let's go to the next question. Question 5. Let z equal x plus y, where x and y are elements of all reals. The rays of this and the ray of that, where z is a complex number, of course, intersects on the complex plane at this point. Find the value of b. Okay, so let's draw these and let's really visually look at them first. How do they look? We can easily do it by CAS, but I want to really show you what they kind of look, what we're looking for. So if I break this question down, so because we are dealing with the Argand diagram, of course, this is your real axis, and this is your imaginary axis. Okay, so let's kind of break this down. So this one over here is just, translated 2 units. So it's 2, 0 because of this. So it has a coordinate at, like, let's say that's 1 and that's 2. So right there, it's going to have an open circle. Remember, they are open circles. Yep. And the angle is pi on 4, which is like, will look like this. So pi on 4, something like that. There it is. So that angle would be pi on 4. That's what this ray would look like. What about the other ray? Well, the other ray would look like this. Well, you will have we'll start at 0.51 because of this. So 51, which is 1, 2, 3, 4, 5. So 5, and translated 1 unit, which looks like over here. Beautiful. Now the angle is 5 pi on 6. Well, if you kind of draw like a straight line here to break it apart, like a really nice like this. So 5 pi on 6 is around here. If you kind of break it, so this is pi on 4 right there. Pi on 6 is around there, somewhere like that. That is that. So there it is. Okay, this is your other ray. And you can see that they actually like intersect at this point right over here. That's your point of intersection. Of course, that's your A value. And of course, the Y value is your B value, of course. So we're looking at the B value. That's what we're looking. Now, we can straight away see that the B value has to be positive. It's above the x-axis, of course, the real axis. So it's not A, it's not 0. And yeah, so what would it be? Well, let's just do it by cats. Let's actually find the equations of these. Let's actually find the equations of both of them and equate them to find the point of intersection. That's so much easier. So let's write that. Let's do that. So what I'm going to do is I'm going to write the first equation because, it's arg z minus 2. So arg, like the argument, can be written in your calculator. Go, complex number tools and go to the polar angle. That's your argument. So we're saying z minus 2 is equal to pi on 4. So pi over 4. And given that z is actually equal to x plus yi. So doing this over here, enter, and I'm going to solve for y, because remember, we know it's a straight line. There it is. This is your equation, of course, x has to be greater than 2, and if it's an open circle. This is our equation of our ray. And we're going to do the same thing for the other one. So, of course, angle again, let's write angle here, and it's going to be z minus 5 plus I is equal to 5 pi over 6, given that, of course, I'm just going to use this here, given this over here, given that z equals that, and I'm going to solve answer, comma, y. And here's my other equation, of course, so I'm just going to equate them, so take this over here, equal it to my x minus 2, and I'm going to solve answer, comma, x. And so this is where the x value is basically your A value, but we want our B value, which you can sub it to any because it's a point of intersection. So I'm going to sub it to this easy one over here, sub those in there. And so your actual B value, your Y value is root 3. So that should be your answer. So choose D for 5D. Yep. Beautiful. Okay, next question. Let Z and W be a complex number where argument of Z is that and the argument of W is that. Find the value of argument of Z to the power 5 divided by W to the power 4. Okay, let's break this question down. Well, Z to the power 5, by using the Moivre's theorem, what happens to the angle? Well, we know, you remember, how it's to the power 5, we multiply the 5 with the angle. So it'll be 5 pi on 2. So can you see how that's the angle? You multiply a 5 in front of it. Done. And what about W to the power 4? The same thing. You multiply a 4 into the angle, which is just pi. And what happens if you divide them, and what happens to the angles? What happens when you divide two complex numbers? What happens to the angles? We know, of course, they minus each other. So what's 5 pi on 2 minus pi, and that is going to give, of course, the argument, which is 3 pi on 2. Now, there's a problem with 3 pi on 2. It's not within our principal argument, so we have to minus 2 pi from it. And if you minus 2 pi, you get negative pi on 2, which is A. Really, really nice question. Generally beautiful question. Let's look at question 7. The length of a curve is defined by this parametric equation that from 0 to pi is given by what? Really nice question. Well, we know parametric equations, like for length, of course, is, you would write T1, T2, the square root of, dx, dx dt squared plus dy dt squared dt. That's your formula. So let's find, the derivative of that first. So dx dt is what first? Dx dt is, 3 cos t. And dy dt is -4 sine t. Beautiful. And of course, squaring those, so, dx dt, squaring those values, we get 9 cos squared t. And squaring dy dt, we get positive 16 sine squared t. All right. So putting it in our formula, of course, t1 is 0 to pi. The square root of adding these two up, which is basically 9 cos squared t plus 16 sine squared t dt. So what's that going to be equal? Well, let's have a look which one's actually equal. It's not A because it's supposed to be actually a positive here. I don't know B, I don't know C. Yep, not E, of course. E looks totally different. There's 4 and 3. Where'd they get those? Yeah. I'm going to simplify. Well, these ones over here look actually kind of simplified in terms of sign. This one doesn't also look right. So what I'm going to do also is I'm going to a little bit simplify it more because can you tell these are in terms of sign? I'm going to get rid of this cos. Well, we're using our identity. You remember how you can write cos. So we write it nicely. So you know how it's 9. And cos squared is just the same as 1 minus sine squared t by using Pythagoras identity plus 16 sine squared t. So we can get it in terms of sine, of course. That's the goal. And so a little bit, you would kind of, expand it out. Minus 9 sine squared t plus 16 sine squared t dt. Why am I writing dt? I'm just a little bit simplifying it here. So that gives me 9 plus 7 sine squared dt. Basically that. Which looks like B would be your answer there. So that would actually simplify to that. Not too bad. Not really. Yeah, not too bad of a question. That's nice, actually. So I want to make this smaller. There it is. Okay, next question. With a suitable substitution, with a suitable substitution, this can be expressed as what? Really, really nice question. Really typical. So what I'm going to do is I'm going to let you be inside the square root, which is that 2x plus 1. So I'm going to, of course, my dx would be 1 over, derive that, which is 2 du. So let me rewrite this now. So you know how the terminal here is 1. So I'm going to sub it to get it in terms of u. So that'll be 3 and 5. If I sub it into that, it'll be 11. So let's start just terminating some stuff. Which one this is wrong because it uses the wrong terminals. That's also wrong. Okay. Now, the thing is this 2x minus 1, I can actually express it because I know if I rearrange this in terms of x, so you know how it's going to be u minus 1 over 2 is equal to x. I can rewrite this x term. It's like 2, and x is u minus 1 over 2 minus 1. And then the square root of, you remember 2x plus 1 is u. And then what's my dx? Substituting it with that, put the half outside du. So you can see that these will cancel out, these 2 and 2. And you get u minus 1, so this will be u minus 2, basically. U minus 2. And that's, again, you can write it u to the power of half, that square root part. All right. So expanding it further, of course, because they all look expanded. So expanding that further, you get u to the power of, expanding that, you get 3 on 2. Oh, let me write it that nicely. 3 on 2 minus 2u to the power of half du, which gives me what? All right, these are all 2 to its e then. Half, yep. 311 u to the power 3. Beautiful. Not too bad. So 8e. So let's have a look at the next question. Question 9. I really love these questions because they're actually a little bit easy. They're so easy with a CAS. I'm going to show you first how I would a little bit try to take some, eliminate some stuff. So looking at it, yep, the differential equation that has the diagram above as its direction field as well. Okay, so just choose any value, try to look at it. Okay, I'm going to choose the origin. Can you see the origin, how there's this slope over here, which is it's a positive slope, yeah? And the coordinate is 0, 0, yeah? So if I sub it in here, it's supposed to give me a positive gradient. So let's sub it into this first one. So if x and y are 0, 0, sine 0, it'll become sine 0, but sine 0 is 0. So that's rubbish because it means that this means that the gradient at that should be 0 because sine 0 is 0. It means it would have been a straight line. It should have been like a horizontal line, but it's actual as a positive, like a positive gradient. So that's wrong. It's actually the same case with C. Again, if you sub in 0, 0, same thing. And actually E also, 0, 0, and 1 minus 0, like 1 divided by 0 is undefined. And so it would have been, for E, it would have been this. It would have been a vertical line. And it's not actually. So look how fast we've eliminated. Now, what I'm going to do is I'm also going to... so this is by hand. I'm doing it right now by hand, how you would normally do it by hand. Of course, there's quicker ways, and I'm going to show you a really quick way. What I'm going to do is, let's say you did it by hand, and you have these two answers, and you're like unsure. Let's pick a point. Let's pick, what point? This point here, which is this point over here. What's the coordinate? -3, 0. So if I sub those points in here, can you see how, by the way, can you see how it's a negative gradient? Just remember it's negative because it's down, slopes down. So if I sub that in here, it'll be cos y0 minus, so it'll be +3. And here, it's the same thing, but it's 1 over cos 3. I'm going to put these in my calculator and see what the actual values are in decimals to see what they are. So cos 3 is that, and 1 divided by this value over here is that. So, they are really close to each other. So can you see how that's -0, 0.98, and this one's -1. So this one's like the gradient's, basically -1, and the gradient of this one's also -1. So they're really, really close to each other. So these actually are not, that's really hard. So, okay, say we don't know how to do it. Do not give up. It's actually so much easier. What we can do is this. Come back to our thing. What we can do is this. If you're like, okay, is it B or D? Just pick a point a nice point on the diagram. So that's best point. Let's say this. I'm going to pick, 0, 3. So I'm going to follow those gradient lines. They look like they're following like this. As you can see, they become straight like that. And then I'm following them nice. And I'm drawing this nice gradient. There it is. And so the coordinate, that coordinate was, again, 0, 3. I'm going to go to my CAS. Let's go back to our CAS. And I'm actually going to graph it and see which one has that kind of, that shape that we drew. So I'm going to go to menu. I'm going to go to graph entry. I'm going to go to differential equation solver. So let's try the first one, which is, of course, cos 1 minus x. And let me just take that out. And the coordinate that we subbed in was 0, 3. And we enter. There it is. It looks the same. Beautiful. Let's try the other one. You remember how the other one that we mixed up is 1 over, 1 over this over here. Enter. And actually that looks like rubbish. So it's actually B. So choose B as your answer. I hope that makes sense how you can break those questions down really, really easily. All right. Question 10. Let's have a try at this. Sand falls from a chute to form a pile in the shape of a right circular cone with semi-vertex angles of 60 degrees. Sand is added to the pile at a rate of this per minute. So they're adding, at this rate. So which is, volume per minute. So let me just write that. And they're putting it in. So your dV dt in is 1.5. Okay. The rate at which the height meters of a pile is increasing in meters per minute. So meters per minute, which is basically dH dt. That's what we're probably trying to find. When the height is so when the height is 0.5, this is what we're overall trying to find, basically in 2 decimal places. All right. So normally, okay, if there's a rate of question, so can you see how we know what rate's coming in? Like your dV dt in is coming out in. So we know that dV dt, but your overall dV dt is your dV dt in minus your dV dt out. Now, of course, we just have in. Out is 0 because there's nothing coming out, so we can rub that out. And yeah, it's positive. It's just positive 1.5. So let's write that down. Just always be careful with that. So let's start to do the question. How do we get dH dt? That's our goal, yeah? We need to find the equation of dH dt. So we can actually rewrite dH dt as, dH dV times dV dt. Because you know how these dVs will cancel each other, and that's that equals, your dH dt. Well, we know what dV dt is. It's that 1.5, the one that we got. So I can right now write 1.5 there. Now I need to find dH dV. So we need to, okay, how do we do that? So we want to get something in terms of volume and height. Well, we've got the cone right in our face. So we know that, by the way, if you look at your, like, what do you call it? If you look at your, so let me just have a look at my formula sheet. What's the volume of a cone, by the way? So the volume of a cone is, so looking at it, is, volume of a cone is 1/3 pi r squared h. Well, of course, this is the height and this is the radius. So let's sub stuff in. 1/3 pi. So first, let's find the radius. What's this radius over here squared? So we're going to just use Pythagoras' theorem because it's just a right angle triangle. We know that this here is the height. We know that this here is, of course, our opposite. This here is our adjacent, and this is our hypotenuse. Of course, we want our opposite, which is our, I'm going to call it r, your radius, is, of course, opposite and adjacent, which is tan. So we can say that tan, the angle, 60, which is pi on 3, is equal to, your radius divided by your height, which hence your radius is multiplying height on both sides. You get radius is just this value over here. And what's tan pi on 3? It's actually just root 3. Write that there. Root 3. Okay. Now, if you're squaring this, remember, we want to square the radius. So if you're squaring that, the radius, it's going to be 3h squared now. So we can sub that in there. 3h squared times, of course, don't forget the h. Which, of course, these 3's can cancel out. There's no need for those. And you basically just get a nice equation. So pi, h, basically h to the power 3 because of the h2. There it is. So now I'm going to actually, can you see how I have volume in terms of height? This is great. So I'm going to derive it. So I'm going to find dv dh first. So derive it in terms of h, which is, bring the 3 there. And h squared, done. And I'm going to reciprocate it. dh dv is 1 over 3 pi h squared. Done. So now look, I have my dh dv. So I can multiply with that. 1 over 3 pi h squared. dh dt. So, and can you see how these will cancel out? Like this 1.5 goes into it twice. So I can write this out and write a 2 there. Okay. There it is. So this is my dh dt. And guess what I have to do? I just have to sub in when height equals 0.5 into this. So when h equals 0.5, and let's solve that. What's that? So going to my CAS. So what I'm doing is 1 over 2 pi times h squared, given that h, we want it to be 0.5. Your h is 0.63 or 0.64 in terms of 2 decimal places, which is C. So 0.64. So 10 is C. Not too bad. All right. Question 11. Let's have a try at this. So let point M have a coordinate this, and let point N have this coordinate. If the coordinates of the midpoint of MN is this, A, B, and C are real constant. Find the value of A, B, C respectively. Quite an easy question. So what do we do if we draw a number line here? So imagine this coordinate here was M, and this coordinate here was N. And so we know the midpoint of them, and can you see how it's not a vector? They've drawn a straight line, means that, it's like the distance there, is MN. Okay. So we know the coordinate of M is what? It's A, 1, -2. N is -3. B, -1. And Mn is -5. 3 on 2. C. Now, it's easy. How do you find the midpoint? Don't we just add the x values and divide them by 2? And we do that for the y, and we do that, of course, for the z values too. Because it's 3-dimensional in this case. So let's add the x values. So what's A plus -3, which is, A minus -3. And of course, don't forget to divide it by 2. And that should equal to the midpoint of the x value, which is -5 in our case. So equal that to -5. That's one of our equation. Do that for, of course, the y value. So 1 plus b, which is basically just, in other words, b plus 1. Of course, don't forget to divide it by 2. It's equal to your 3 on 2, your y value here. Same case for the other one. -3, because -2 plus -1, which is -3, divided by 2 is actually just equal to your c. So we already got our c value. Look how easy that was. Your c value is over here. So which one has that c value? Oh, we can actually cancel a lot of stuff out. Okay. So let's also find b. Well, it's easy to find b because can you see how both have the same denominator? So we can cancel those out. And b equals 2. And you can cancel that out because this one only has b equals 2. And of course, a has to equal -7 because it makes sense. -7 minus 3 is -10 divided by 2 is -5. So that also works. Not bad. Question 12. So the vector resolute of this in the direction of this is actually this, where m and n are relative constant. Find the values of m and n and p can be found by solving which equations? I'm just going to do this with CAS. It's really, really easy how to find vector resolute. So we know so let's denote some vectors right now. So let's denote this vector as A, and let's denote this vector as B. And so of course, when we're writing it, so to denote the vector, resolute, we're saying A dot B, the dot product, over because it's in the direction of B, so B squared dot B in the direction of B. So this is what we want to write in our CAS, and hopefully it gives us a nice equation. Of course, and that whole thing equals this, your vector resolute, which is, your 2i minus 3j plus k. So let's write that down in our CAS. So I'm going to define A, the vector A, so which is what? 1, 1, -1. B, the vector B. So the vector B is MNP, so MNP, and so we know to find the dot product is going on menu, matrix, going down to vector resolute, and it is called the dot product. Of course, the dot, you're finding the dot product of A and B, and to find the magnitude, it's called norm. So norm of B, we want to find the magnitude of B, but we want to square root, of course, don't forget, and times B. So this whole expression actually gives you the vector resolute. It's equal to our vector. What was our vector? What should this equal? Remember how it equals, let's write the vector. What is it? So 2, -3, and k. Enter, and here it is. These are our simultaneous equations that you would normally solve for to get your values. So you've got this one over here, this equation, and this equation over here, which look like, going back to our thing, it looks like A is the answer. So m n minus p, m plus n squared, equals 2. There it is. This one's that one. Beautiful. So 12, A. Question 13. Two forces F1 and F2, both measured in newtons, act on a mass of 3 kilograms, producing an acceleration of this. Given that F1 is that, find a acute angle between F1 and F2. Okay, so we know what F1 is, but we don't know the force 2, which we can actually easily find because they've given us the mass and they've actually given us the acceleration. So think about it. We know that the sum of forces, this is Newton's second law, that the sum of forces, so the sum of all forces is times, mass times is equal to mass times acceleration, Newton's second law. Well, the sum of forces means you're just adding these forces. Well, we have two forces. We have F1 and F2. So imagine adding these forces up. So F1 plus F2 is going to be equal to your mass, which is, of course, 3 kilograms, times your acceleration, which is, they told us that it's root 3i plus j. So what's F1? Well, we know F1 is 2j, and we're trying to find F2 in this case. So F2 is kind of, expanding this. We get 3j. I don't want to make any, so F2, the vector F2 is going to be 3 root 3i plus j. So we also have now the force 2, like the actual equation, which is great. So what we're actually trying to find is the acute angle between them. So imagine, if I know so imagine this is this force here, and this is the other force, and we're trying to find this angle between. So let's call this F1 here, and this is F2. And this is the angle that we want to find them. We're going to use, of course, your F1 dot B, F1 dot, so scale multiplication. So F1 F2 is equal to the magnitude of F1 times the magnitude of F2 times cos theta. This is how we're going to get our angle between them. We're going to use this. That's our goal. So your multiple, first we're going to try to multiply, of course, the dot product of F1 and F2. Well, that's easy because we know that we're trying to find, this one only has j. So what's 2 times 1? It's just 2. So the dot product is 2. That's 2 equals. What's the magnitude of F1? Well, it's just 2, as we can see here. And what's the magnitude of F2, which is this? Well, the magnitude of this one's actually, so what's 3 squared? So that's going to be 9, and that's going to be 3. And then what about 1 squared, which is just plus 1? That's going to be 9, 18, 27, 27, plus 21, plus 1 is 20, root 28. So 28, which is equal to 7, 14, 21, 28 is equal to 2 root, so 7, 14, 21, 28. Yeah, so 7, 14, 21, 28. Yep, so it's 2 root 2. 2 root 7, yep. 2, so that's right there, times 2 root 7. That's your F2, the magnitude cos theta. Okay. Now, you can take these 2's out because they're multiplication here. That becomes a 1 here. And now divide both sides by 2 root 2. 2 root 7. And that's going to give you your cos theta. And of course, we can find our angle by just stating that, your theta is just the cos inverse. Now, be careful. This is an acute angle. Remember, this is an acute angle. There are 2 cases that we need to be careful here. It could be the acute angle or it could be the obtuse angle. And those are, okay, so these are all wrong, by the way. It could be this scenario or it could be pi minus arc cos. So how do we know the difference? So one of the ways that you can tell the difference is we know that if the dot product, so in between, like let's say A dot B, if we know the dot product is positive, it's greater than 0, then the angle has to be between 0 and pi on 2. So it has to be an acute angle. But if your dot product is less than 0, then the angle has to be between pi and pi on 2. So this is important. Well, didn't we find out dot product for this one was 2, which is positive? So it's actually the acute angle. So it's actually, we just leave it as what it is right over here as our answer, which is cos 1 over 2 root 2, which looks like question 13D. Beautiful. I skipped this question again, not on the study design. Mechanics is taken out. Question 15. Let's have a try at this. A particle is moving along the x-axis with a velocity of this, where u is a real constant. At time t equals 0, a force acts on the particle, causing it to accelerate with the acceleration of this, where a is a negative real constant. Which of the following statement correctly describes the motion of the particle from for t is greater than 0? So the particle slows down, stops momentarily, and then begins to move in the opposite direction to its original motion. The particle continues to travel along the x-axis with decrease in speed. The particle travels parallel to the y-axis. The particle travels along a circular arc or moves along a parabola. So this is actually not too bad, because what we can do is we can kind of, we're given so much like hints. So for example, we know the acceleration here formula is alpha j. Yeah, we know the acceleration formula. So if I integrate that, I can find velocity, you remember? Which is, alpha t, alpha tj plus c, where c is a constant. But we're also given a hint. We know that that it was, before it was moving at this velocity. You remember how it was moving along the x-axis with this velocity? So it was actually at t equals 0. It was moving at this velocity. So we can that's going to give me, my velocity would be ui. So when t equals 0, that's your c basically. So your velocity can be written as alpha t j plus ui. And so I think getting the position would be more easier, because if you get the position, like your position formula can tell you how it's moving. So position is what? Of course, antiderivative again, t squared on t j plus ut I, and don't forget that plus c, another a constant, and that plus, assuming that it starts at the origin, of course. Let's say assume that it starts at the origin. Don't worry about c. It's just a constant. It doesn't really matter. And you can actually see what it is. Like make the formula. It's easy, because remember how the I component. So we know that this I component over here is, in terms of it's the x component, and this here is your y component. So your y. So think of it like this. Your y is equal to alpha t squared on t, and your x is equal to ut. So divide both sides by u for this one, so we can get in terms of t. And I'm going to sub this t inside that y to get the equation, y equals what? So, t squared is basically x squared u squared, all being divided by 2, which is alpha x squared over 2 u squared. So that here is my equation of my actual path. Now be careful. They told us that alpha was negative. So it's actually a negative, let me rub this out. It's an actual negative parabola. If you think about it, it's a negative parabola. So it will look like the path could look like this. So if you're drawing this in a Cartesian plane, the path of this particle would look like this. Of course, you know, it starts at the origin. You can see it starts at the origin. A is negative, so it looks like a negative parabola like this. Yep. Now be careful. Of course, there's something wrong with it. We know that, you know, first of all, t is greater than 0. Like t is times greater than 0. And I'm so sorry. I kind of rubbed the formula. It was, if I'm not mistaken, it was, oh my God, x is equal to ut, yeah. So, you know how we got x is divided by u equals t, and we know they told us that time is greater than 0. So if this thing here is greater than 0, times both sides by u, so x has to be greater than 0. That's your domain. So we have to take that out. This is what it will look like, basically. Your path of the particle will look like this, which is a parabola. You remember, it's just a parabola, but half of a parabola, only taking the positive side. So let's have a look at these statements, all of them. The particle slows down, stops momentarily. Wait, the particle slows down, stops momentarily, and then begins moving. No, it's not. It's just moving in one direction. It doesn't even slow down. You can see that, you know, it's low, you know, it has a low because remember the velocity or the speed is the gradient, and you can see that it doesn't, you know, it just increases in speed. So that's not right. The particle continues to travel along the x-axis with decreasing speed. Absolute rubbish. You can see how it's like a parabola and nothing with it's traveling along the x-axis, and it's not decreasing in speed. It's actually increasing in speed. You can see how it's increasing in speed. The particle travels parallel to the y-axis. Absolutely not. The particle moves along the circular. No, remember, it's not circular arc. It's a parabola. So like E is a more better one. The particle moves around because it is a parabola equation here. It's not a circular path. Yeah. All right. Question 16. A variable force acts on a particle, causing it to move in a straight line. At time t seconds, where t is greater or equal to 0, its velocity v, v meters per second and position x meters from the origin are such as this. So this, we have the equation. The acceleration of this particle can be expressed as well. Really beautiful question. So we have v, and it's in terms of x. So I want to find the acceleration. So we can use one of our acceleration formulas, which I would use in this case is so acceleration can be written as the derivative, the d dx of half v squared. So you know how we know v is that equation here. First, I'm going to v. What's my v squared first? I'm just going to square everything. 2x, that'll be sine squared x. Yep, that's v squared. And I'm going to multiply it by a half. A half in front. Move this a little bit to the side. Half. And then I'm going to derive it. Of course, I'm going to try to derive it. d dx. In terms of x, of course. You remember, in terms of x. Derive it equals what? So let's derive this. Of course, you're going to be using the product rule. There's two things being multiplied, which in this case is, of course, yeah, u is going to be our, half. I mean, let's just do by our heads. It's really that easy. So this is our u and this is our v. So it's, it's going to be half e to x times v dash, which is, you can write it as sine x squared. We bring that 2 in front. Derive sine, which is just cos x. And then, rewrite it by minus 1 to the power, which is just sine x. So we can write that. 2 cosine x sine x. Okay. Making some progress here. This is great. Okay, so that, yep, plus, sine squared x times the derivative of this, which is, derive the top out, which is just 2, bring that 2 in there. It's just e to x. Okay. So, these halves can cancel out. Just with that 2 there. So we can bring that there. And you can see that there's a common factor of e to the 2x. So we can actually take that e to the 2x. But this is now is acceleration. This is equal to acceleration, this whole formula. So this is equal to, so e to x cos x sine x plus sine squared x. So which one looks like that? It's not b because this one's e. It's our one's e to the power 2x. It doesn't look like that one. It's e to 2x. And I think we need to simplify it. Yeah, which one would it be? So, like, let's have a look at the first one first. The first one, e to the 2x. We have a sine squared, but then they're saying it's half sine 2x. Okay, wait. Well, we know what's half sine 2. So, we know that sine 2x is 2 sine x cos x. And that's, cos sine x, but basically, yep. So, if I divide by 2, so times it, like, divide both sides by 2, which is a half. Yes, I can actually replace that part here with this over here, which is half sine 2x. There it is, actually. Yes, we can actually do that, which is half sine 2x sine squared. Yep, it's actually A in that case. So let's choose 16A. So this is, again, this is mechanics, not a study design. Question 18, so probability. The masses of a random sample of 36 track athletes have a mean of that. The standard deviation of the masses of all tracks athlete is known to be that. A 98% confidence interval for the mean of masses of all athletes correct to 1 decimal place is what? A really easy question, just use your CAS. Let's do that. So to find out if, the 98% confidence interval, go menu, go to statistics. In specialist, you use Z interval. And present stats, okay. So what was our standard deviation? Well, it was 4. What was our mean? It was 65. And how many, the sample was 36, was it? Yep, samples of 36 athletes. And we want, what was it? 98%. Press enter, control enter, and here's our C lower and C upper, which to how many decimal places? 1 decimal place, that's 63.4 and 66.6, which looks, so it's 63.4, so it looks like, so 18 is D. Beautiful. Not too bad. Question 19. X and Y are independent random variables with each having a mean of 4 and a variance of 9. Beautiful. If a random variable Z has a mean of 8 and a variance of 90, possible values of A and B are what? Okay, so we can easily do this. Okay, so what we can do is, okay, we're trying to find, we know the mean and the variance. So the mean of Z is the mean of AX plus BY. And we can separate those, break them apart like this, plus expected value of BY. And you can take those constants out for the expected, so EX plus B expected value of Y. And we know that the they both have the same expected value because they told us that each have a mean of 4. So this will be 4A plus 4B, and that's equal to expected value, which has an 8. So basically, this is our equation done. That's the first equation. And so I'm going to write, this is our first equation. Let's do the other equation. So we know the variance. Well, same thing. Variance for Z is the variance of AX plus BY. And again, break them apart. Variance AX, AX plus variance of BY. But the thing about, if you're going to take the constant out for a variance, you need to square it. So A squared variance of X plus B squared variance of Y. Okay, and so we know that is going to be, so you remember the variance for both of them is 90. So it'll be 90 A squared, sorry, what am I doing? Not 90, 9. So 9A squared plus 9B squared, and that equals all to 90. So put these two equations in your CAS and we can find the values of A and B. So let's do that. So go on menu, go to algebra, solve system equations, just go solve system equations. We're trying to find A and B. So the first one is, oh, sorry. Let me just control N everything because I think A and B are already defined. So let's go again, do it again. All right, so A and B. Okay, so the first one is, of course, A equals 4A plus 4B, and the other equation's 90 equals 9A squared plus 9B squared equals, and these are our two values that we can have. Now, which one are those? So A equals -1. Nope, that's none of them have that. So it has to be A equals 3 and B equals -1, which looks like 19C. Beautiful. Question 20. The random number of function of a calculator is designed to generate random numbers that are uniformly distributed from 0 to 1. When working properly, a calculator generates random numbers from a population where the mean is that and a standard deviation of this. When checking the random number function of a particular calculator, a sample of 100 random numbers was generated and was found to have a mean of that. So we have like this is our mean, the average, but we have a less than the average. Assuming that, of course, the null hypothesis is that, and the alternative hypothesis is of course, where the mean is actually less. So we're trying to test if is the mean less than what's that 0.5. And this is your, again, same standard deviation for p-value for one-sided statistical test is what. So we're just trying to find the p-value. It's a really actually generally easy question. So what we can do is kind of really visualize what's happening here. So if I draw a nice normal diagram here, imagine that's your x bar here, and this is your mean. Now the mean doesn't change. So you remember your p hat, when you're finding the p-value, you're assuming that the null hypothesis is true, and you're trying to find the most like what's the probability of actually getting that. So this is what we're trying to say. That 0 point this here, which is around here, 0.4725. Yep, right over here. We're saying, what's the probability that it's actually less than that? What's the probability? This is your p-value, and this is what we're trying to test out. This is our p-value, which is easy. It's just the p-value is the probability. Your x bar is actually less than that 0.4725, assuming given that your mean is actually 0.5. That's your p-value. So we can now be careful. So you remember, x is of course normally distributed, where it has a mean of, the mean doesn't change, so 0.1, but your standard deviation changes. Remember, your standard deviation of your mean, of your sample mean, is your original standard deviation, which is that, over the square root of n, your sample size, which in this case was, how many did we use? 100. So it's actually just the square root of 100 is 10. So that. So let's put this in our class and let's calculate it. So let's first find the mean. So that 0.8 divided by 10. No, sorry. Let's find the standard deviation, which is that. Yep. And let's calculate it. So go menu, probability. Let's calculate the p-value now. Sorry, what am I doing? Go to normal CDF, of course. We know the standard deviation, and we know the mean is 0.5. And, we're going, yep. So, and your upper bound would be that 0.4725. Press OK, and this is your p-value, sorry. So 0.1704, which is 20B. Beautiful. That is it. I hope you guys enjoyed this video and learned something through it. Please make sure to like and subscribe, and I'll try to make as many videos as, to try to help as many of you guys. I hope you guys enjoy your holidays. Have a great day. Bye-bye.